Okay, today's demo is choosing the right table saw blade. Blade. The right table saw blade. So before. No. Sweet. See, you're ahead of yourself. We're going to do this next week. But to pick the right blade, you kind of need to know what you want to do. And then they make the blades that will correspond to what the needs are. So let's talk about blades. The first thing we need to talk about is the size of the blade. For most table saw, that's a 10-inch blade. Okay, a 10-inch blade from center to here, 10 inches. Not a whole lot of verbal clutter there. When we talk about from here, well, I mean, actually from here to here, it's 10 inches. 5 inches from here to here. One thing I do want to talk about first, though, is the disc itself. If you look at these discs, you'll notice that the teeth are wider than the disc, because we don't want the disc in the wood, because that's going to generate a tremendous amount of or this. That tells us something is wrong with the table saw. So how do we determine what's wrong with the table saw? The only way that this could happen is if wood is rubbing against the disc. Okay? When we cut wood, it's going to do three things. It's going to stay the same, it's going to open up like this, or it's going to pinch closed. Most people think when it pinches closed is when it does this. And normally that's not the case. Normally in this distance, it's not going to get so tight that it won't start cutting here. And if you're holding down good with something to hold it down, you're going to be pretty good as far as kickback goes. We don't encourage it, but this really, because normally you're only protruding this far. Now to go down here, that blade was fully extended. Okay, so what causes this? Two things. The one thing could be the wood warpage. Now we have the pinch, and people think the pinch one is the one that can cause the problem with that. Actually, it's not, it's the expansion. Because you've always got this wood against a fence. So when the wood starts to expand, it can't move this way because there's a fence there. So it turns the whole piece cattywampus this way. And now you start getting friction on this side. So that could be one thing. Another thing it could be is the trunnion itself is moved. Trunnions are what the saw blade sits in. They're independent of the table saw body itself. And every time you turn that motor on, that motor kicks it. There's no soft start in the table saw. It just kicks it. And you're going to, over time, that's going to cause the trunnion to move just a little bit until it's no longer lined up with the miter slots or your fence. When that happens, you're going to have a saw blade that's like this, and you're pulling wood in here. So as you cut, it's still going to cut, but now on this part of the saw blade, you're going to get all this wear. So what you want to do is you want to look at your saw blade and see, well, here's some serious wear here, but there's none on the other side. So this is sitting in this, so most likely this blade got, the trunnion is turned, and we're getting rubbed right here because it stops for all the parts that are below the table saw. Up here where it's above it, we've got this nice rubbing. So if you see any type of rubbing on your disc, something's wrong. Most likely, if you've had the saw for a while, it's the trunnion. Sometimes it could be wood. Here we're going to look at this. Got the same thing here. We flip it over this side. You've got some wear marks, but not near as much as this. So this is a good example of a pinch, but this is mostly trunnion. So it's more common than people realize. So if you start seeing this on your saw blade, then you need to think about making the trunnion move again. Another thing I want to talk about is the tooth set and what we're going to do with the tooth set. There's basically 5 tooth sets on what we buy. The most common is called the alternate bevel. So we have the carbide tips. Now the carbide is welded onto the blade after the blade is formed. So they have these big machines in these big factories, and they just run through there, put the carbide tips on, weld them solid. Then the blades go to the grinder, and the carbide is shaped with the diamond grinders. Okay? And an alternate top bevel is going to look like this. We're going to have two teeth sitting like this. Normally there's about 40 of them or more, because this is a cross-cut tooth. And this is designed to cut all the way through the piece of wood. This is not designed for a dado cut, which means it doesn't go well because you're going to leave a little tent poking up in the center if you try to do a dado cut. So this is the most common tooth set there is. It's designed to get a score line and a score line. So if you're sawing in wood, you get a nice, crisp, clean edge. But this is the shape. I mean, all the cutting is done up here. Down here, it's just trying to get out of the way. So all this is where the cutting is going, because as this comes through, every part of this top part is going to touch the wood. Alternate top bevel. The next big one you're starting to see more and more of is this one. This is called high alternate top bevel. The pyramid is much bigger. This is really designed for plywood, or woods that like to splinter. Because of these are so high and sharp, they do a really good job scoring and give you a nice, good, crisp edge with no tear out. Okay? On the top. On the bottom where it comes out, you can get tear out. It shouldn't be as bad as the normal tooth set, but you could get some. But this is designed mainly for plywoods or any type of blade that says it's going to give you a nice, smooth cut on the edge of the wood. You'll normally find this tooth set. The disadvantage of this is there's not a lot of steel up or carbide up here, so these will dull quicker than the normal alternate top bevel.
With that on the plywood, you'd want your good side up.
Yep, absolutely.
So that they don't wear out or
That's,
tear out.
That's exactly correct. A good side up. Anytime you're cutting plywood on a table saw, good side you always want up. Because no matter what the tooth is, it's going down, so you've got the wood underneath the back. This next tooth set is the simplest there is. Now remember, all these are designed for through cuts. We're cutting the wood in half. This is a rip tooth. Okay, it's nothing more than just an old chisel that somebody got the idea, let's put it on a saw blade and just, but that's a rip tooth, okay? Flat. So if you used a rip and didn't go all the way through the wood, you'd have a flat bottom like a dado, okay? This is called a triple grind chip. They use this on surfaces that are really hard. And you've got the triple grind come through first, and then this little raker cleans it up. If you can see, the triple grind takes out the bulk of the wood, and that raker just takes a little bit to clean up the cut. Okay? This one will also give you a flat bottom if you're doing the dado. But anytime you look at wood, a lot of times you'll see this on stuff that's going to cut melamine or just something a little bit harder, you'll get this tooth set.
That be used on, what's that? It's got a smooth surface, it's hard. MDF? Laminate, not laminate, but
Laminate would work?
no.
Melamine?
Huh?
Melamine? Yeah, works on melamine.
So you use something like that, something.
Harder, right. Anything that's a composite, composites are wood and glue, and the resin or the glue they use is extremely hard. So this is what you'll normally find in the tooth set for those blades. And last but not least is called the combination blade. And this is one of the first this is how the first combination blade came about. This is a rip tooth. This is a crosscut tooth. And they wanted a blade that would do both. So they did this. And that was the first combination blade. It does ripping, and it also does crosscuts.
That's what it's called, combination.
Combination. Okay. This will also leave you a flat bottom for a dado. So, this is what they look like in real life. Here's a combination blade. Yeah. Thank you very much.
Well, if I need it.
Just throw it in there for me. And I'll just set this over here. And here you see the 4 teeth right here for the alternate top bevel. And then in front right here, alternate top bevel, here's your raker tooth. The raker tooth is in front of this big gullet. This tooth will generate lots of shavings because it's scooping out the wood, and all those shavings go there. The little teeth, since they're just taking out little part of wood, you need much smaller gullets. But this is a combination blade. This is what it looks like. And you can see that it's good for a lot of stuff. It's not excellent for a lot of stuff, but that is a good general purpose woodworking blade that's very sharp. This one is for solid surfaces. This is the triple grind. So there's that little triple ground tooth here, the raker behind it, the triple ground, the raker. And this is for those real solid surfaces. And here you can see that this is really good for solid surface, for plexiglass, vinyl. So any of those type of surfaces, this is what you want.
Does it matter the amount of
It does as far as cross cuts or rips. Normally cross cuts, you want a lot of smaller teeth. Rips, you want fewer bigger teeth, just because the amount of sawdust they generate.
I was looking at the difference in the blades, and there's more teeth on that than there is in the other one.
This is a heavy duty rip. This is not good for cross cuts at all. Thank you. And here you can see big, huge teeth, great big, huge gullets. Very, very sharp. Yeah. Ripping. Ripping. Yeah. And just to show you about the wear and tear, this is what those blades at one time looked exactly the same, but you can see where the wear was on this one. And then you can also see how damaged the teeth are, how worn down they are. Okay. And last but not least, we have our, this is both, think of this as alternate bevel and high alternate bevel. This is a high alternate bevel. This is the Fusion. I've got 2 of these, so I must like them. Very, very sharp. But when you look at these, these are the ones that you ow, 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 because these are really sharp little points right here. Be very careful with this one. You might want to hold it like this because these will poke you. Okay.
What is your recommended number of reshots?
3.
3?
Mm-hmm. We'll talk about that in just a minute. Okay, so those are the different tooth sets, and that also gives you an idea of the size of the teeth that you're supposed to see on those. The more cross-cutting you're doing, the more teeth you're going to have, but the smaller they're going to be. They're going to take little bites out of that grain. It's taking the long grain and this is trying to scoop this out. And so it needs to be bigger teeth. They need to be fewer so it can scoop it out really well. The biggest example I've got of a blade that does nothing but scoop out, if you want to use hardy board, which is a concrete-based board, to cut it you need a hardy blade. And this is a hardy blade. It's got 1, 2, 3, 4, 6 cutters. That's it. Big stuff here, but this is designed to cut concrete, a concrete fiber board like a hardy board. Hardy plank, hardy trim, hardy this, hardy that. This concrete fiber. So you can get saw blades that are designed for very, very specific things. So you really need to know what it is you want to be cutting. If it's wood, we got you covered. So the next thing we need to talk about is we talked about the tooth and the different tooth sets that you're going to expect to see. The next thing that people have problems understanding is the rake of the blade. And what we mean by that is if you started in the center and drew a line straight up, just like this, straight up to where it hit the teeth, and the blade is going in this direction, table saw blade's coming this way, okay? If the tooth was dead even on that line, we would say 0 degrees, which means that it's not trying to help the cut, it's not trying to hurt the cut, it's neutral, okay? So we're going to use that when we want to control the rate of the cut. You don't want the saw blade, the wood jumping out of our hands or the saw blade kicking back or anything, so what we would use. It's rare to find that. All the offsets, the vast majority are going to be positive, a couple are going to be negative. If it's a positive rake, in other words, it's tilting towards the cut, as that blade comes down and touches the wood, it's actually going to pull the wood into the blade. The higher the degree of rake, the more it wants to pull that out of our hands into the blade. So, when we talk about standard saw blades, we talk about, like, for example, this. Here it is. This is our combination blade. This is our fusion. And this one, 3 bevel. So this one, that teeth is over 30 degrees. That's a very, very aggressive cut. It's extremely aggressive. But then you think of this is on a, you've got this here running at you. You put the wood in, this is going to grab the wood and it's make your job easier. It's just going to be the easiest pie to push this through the wood. Doesn't matter if it's softwood, hardwood, thick wood, thin wood. This is going to facilitate pushing it through. You're not going to have struggles. It's not going to buck you, okay? How do you know when this is getting dull? When you really push to get the wood through. This should be effortless. So a 30 degree is really good for a table saw. As a crosscut saw, one of these coming down, you wouldn't want it. Because as you're trying to control the wood as you're cross-cutting, it's trying to just, if in here to cut the wood and you're not moving fast enough, well, if it can't go this way, it's going to come this way. And you don't want that kickback. So table saw, 30 degree. This is one of the steepest ones I've seen. And let me tell you, this blade cuts like a son of a gun. It's effortless. A normal solid surface blade, this is 0 degree. This is solid surface. This wants you to cut, but it wants you to cut slow. Think about what you're doing. It's not trying to rush you. It's not trying to fight you. This is a 0-degree bevel. So if we were to draw this line straight from the center all the way up, the face of this tooth would be in absolute line with that. All this means is you got to push it a little bit to get it to cut.
So which one would be the better of the two on the tablecloth?
It depends on what it really depends on what you're cutting. If I'm cutting solid surface, I want the solid surface blade because I want to control how fast I go through there. If I'm doing a lot of cross cutting, just general combination, I could rip, I could cross. I'm doing a lot of projects, I would use the Fusion. Tile turnout top bevel. It's going to be great against plywood. It's going to be great against regular wood. It could rip, it could cross cut, it can do it all. It can't do it, it can't rip as well as a dedicated rip. It can't do a cross as well as a dedicated cross. But for everyday use, if you don't have money for a lot of blades, that's the one you want. It'll do it. This one here is again, especially this is because if you've got a long piece of wood you're ripping, you want that saw to help you get that wood through the blade. And it's going to do a very good job of that. This one, this is that combination, the one that started it all. This has got a 10 degree. So it's a little lean forward. It'll help you get it through, but not as much as the 30 degree or not as much as the 20. Again, more controlled cut, more controlled speed. Why doesn't it want you to go too fast? Because of these small little gullets right here. If you push this through as fast as you could put a normal rip, you'd fill these gullets with sand, with sawdust. They'd be pushing out the sides and they would scorch, really scorch the wood that you want, especially if you're using cherry or maple. It'd burn out like the son of a gun. So this makes you push the wood through slower to give these small gullets time to clear the wood. And that's basically one of the big differences. If it wants to go through fast, it's got big enough gullets to clear those gullets when it passes through so that doesn't allow the scorching. So, how do we know all this stuff? Well, on the Freuds, it says right on the blades what they are. The degree of hook, the combination, all the stuff. The Forests do the same thing, but instead of on the blades, you'll see these things right here. And all the manufacturers of saw blades should have this information that you can see before you purchase the blade. Okay? In this particular one, the Woodworker 2, this is the standard, this is the most beloved blade in America today, as the Forest Woodworker 2. It comes in 30 tooth, 40 tooth, it comes in 48 like this one. This is a combination blade, but this is more skewed to the cross cutting. It's a 0.125 standard kerf. What's 0.125? Eighth of an inch. Okay, this is eighth of an inch. Those are all eighth of an inch. That's a standard kerf. This is 20 degree hook face, 25 degree alternate top bevel. So 25 alternate top bevel is the same on the Fusion. The Fusion had a 30 degree hook face. This has a 20 degree hook face. This will also tell you the normal thicknesses. This says excellent for ripping up to 1.5 inches. Why doesn't it say 2? Because the teeth are in the wood longer. So if you've got sawdust poking at the sides of the smaller things, it starts to burn. It won't do that at 1.5 inches thick, but it'll do it at 2. That's the only thing this recommendation for is for if you're doing wood that really is susceptible to burning. Cherry and maple, those are the biggies, especially cherry. You'll look at cherry wrong and it burns. This is what's going to help you decide whether the blade you're looking at is going to be what you really need. We look at this one. This is a thin kerf. We know because it says 0.100. This is 0.125. Okay, so they took almost a 25% of this off. Not quite. So what is the thickness of this? If that is 1/8 of an inch, it's also 2/16 of an inch. It's also 4/32 of an inch. This is 3/32 of an inch. Doesn't sound like much, but it takes 25% less power to push this through a piece of wood than it does this. That's why these are what you buy for low-powered saws. The 1.5 horsepower, the 1 3/4. You want thin kerf blades, okay? Because they can push the same amount of stock, but because there's 25% less blade, it goes through 25% less power to push it through. Make sense to y'all? Okay. This is 20-degree hook face, 20-degree alternate top bevel. Again, you're good to go. This tells you what it's made for. Yeah.
The question is, you just said that that's a thinner blade.
Mm-hmm.
I lost my train of thought.
It's like I do that all the time.
But, oh, that's what it is. You're saying the saw, depending on the horsepower, depending on the blade?
A 1 3/4 horsepower table saw will take a 1 1/8 blade. Oh, I'm sorry, an 1/8 inch blade. I've stopped a table saw with a piece of wood on a standard kerf 1/8 of an inch on a 1 3/4 horse table saw. I've stopped it. Blade went, eh. You have to turn everything off, get the wood out of there, and just take little more cuts. So you raise the blade up maybe 1/4 inch, pass it, put it back, raise it up another 1/4 inch, pass, and that would take off smaller chunks. So the horsepower really depends a lot of what happens with the blade. Another thing that you need to worry about is there's a reason why the 1/8 of an inch is a standard. It's because for just about every saw there is, that motor is moving that blade. When the blade hits resistance, the blade will flex. It will do this. In 1/8 of an inch, that's almost undetectable. At 3/32 of an inch, if you had a high-speed sammer, you could see it. You can see that. So you might be doing, for example, when I do Celtic knock pins. Celtic knock pins are one of the few things in turning that I do that requires a really high degree of precision. Because if you don't have it, then the knots don't come out right. And the precision, one of the ways it has to be, it's got to be exactly what I put the insert material in. It's got to be the exact same thickness as that saw kerf. Okay? So if I'm using a 3/32, the thin kerf, and I cut it, and I got some wobble, then it won't be exact. Some parts are going to be tighter, some parts are going to be too loose. When I glue it up, it's not going to sit quite right, and you'll never see it till you turn the pin. And when you get down to the final dimensions of the pin, any irregularities like that are really going to stand out. So because I've got a 5 horsepower table saw, and when that puppy cranks up, it's got a lot of force behind that blade. So when the thin kerf hits that wood and the wood at first doesn't move, it sends all kinds of ripples. So I have a blade stiffener. A blade stiffener is a discus steel that, in my case, I've got a forest one. It's about that big. And it just sits out, and by clamping that down here and holding it tight against the center of the saw blade, it takes a lot of that ripple out. Now that means because it's so high, since I've got a zero clearance insert, I can only get the blade about this high out of the saw before the bottom of the stiffener hits the bottom of the insert. But since normally I'm cutting stuff no more than 3/4 of an inch anyway, it's not an issue. So you got some play to take it out. Mainly only use those for the 3/4 inch, the thin kerf blades. If you've got a 1 3/4 horsepower, you're probably not going to see that vibration. But if you have those thinner blades and the more powerful motors, yeah, you can see that because they're hitting with some force behind them. So I got this out because I wanted to show you, mainly we're talking table saw blades. However, there are some table saws that do take 12-inch blades. But I got this for another reason. This is what we have in our chop saw in the back miter saw. And this is a nice 12-inch because it's a cross-cut blade. All these little things here, and these are all in good shape. I've looked at these. These have just been sharpened recently. But look at the rubbing. Okay? Now, the chop saw doesn't have a trunnion. It ain't the trunnion. So what causes this rubbing? This is caused not wood expanding. This is caused by the wood shrinking. And now this blade is big enough so I can have some nice shrinkage by the time I get to here.